So today we're going to talk about matrix multiplication, and that is multiplying one matrix times another matrix. Now, you cannot always multiply matrices. They have to meet certain minimum requirements in order to be multiplied. And those minimum requirements have to do with their dimensions. You can only multiply matrices of certain dimensions. So here's the dimensions that you can multiply. You have one matrix and it's an m by n matrix. The second matrix has to be n by p. In other words, this dimension here and this dimension here have to be the same. If they are not the same, you cannot multiply them. And the matrix that you get as a product will be this. It will be m by p. So the ending matrix that you get will be an m by p matrix. So if we look at this first example, it says find a times b. So first of all, a is a, whoops, I already did it backwards. 1 row, 3 columns. All right, so it's a 1 by 3. B matrix is 3 rows, 2 columns. Since these two numbers are the same, you can multiply them. And what you get as an answer is a 1 by 2 matrix. That is this by this. All right, so that's how the dimensions play into this. So our answer to this problem is going to have 1 row and 2 columns. So let me go over here and start a matrix. And I don't know what my numbers are going to be, so I'm not going to put my back end of this on. But I will tell you, you can do this on your calculator. You're going to have to get used to using parentheses. All right? Here's how this is going to work. What goes here is this row times this column. And the way it works is this. I'll write out all the computations for you. So this is 22 times 20 plus 15 times 30 plus 6 times 48. So it's this times this plus this times this plus this times this. That is what goes right here. So now, of course, this is going to be a ginormous number, but I got to do it anyways. So using my parentheses, 22 times 20 plus 15 times 30 plus 6 times 48. Big number? Yep, 1,178. So that's what goes here. All right? So now I need to do the next term here. And how this is going to work is it's this row times this column. All right? So here's what I've got. I've got 22 times 15 plus 15 times 20 plus 6 times 72. And I've got to put that in my calculator. $1062. So 1062. That is my answer. All right. So as you can see, I mean, it's not really difficult. It just takes a lot of calculation to get it done. And writing out the dimensions and being able to check that you can multiply and see what size your answer is helpful. All right? Because really there's only 2 calculations here, this one and this one. All right? So let's go ahead And you'll see further on down the page it says matrix multiplication is not commutative. And what that means is you don't get the same answer if you switch the order of the matrices. In fact, sometimes you can't even multiply them if you switch the order. All right, sometimes it'll only multiply in one direction. So first of all, let's go ahead and multiply this one right here. And first of all, A happens to be 1 row, 2 columns, so it's a 1 by 2. B is 2 rows, 3 columns, so a 2 by 3. It's okay to multiply because the two middle ones are the same, and my answer is a 1 by 3. So I'm going to go over here and I'm going to start my answer. So first of all, my calculation for this is 3 times 1 plus negative 1 times 0. And I think in my head that equals 3. So stop me if I have miscalculated. So that's my first answer. I'm going to do it with the second row now. So I've got 3 times 0 plus negative 1 times 1, which just gives me negative 1. All right, and my last one is this same row times this column. All right, so here's what I've got. 3 times 2 plus negative 1 times negative 1. And I think that will give me 6. So that's my last number. And there's my matrix. Now, as an example, let's find B times A when the order is switched. And here's what you're going to find. B has 2 rows and 3 columns. So it's 2 by 3. A is 1 row and 2 columns, which is a 1 by 2. When you look at these, the two middle dimensions are not equal. So guess what? This multiplication is what we call undefined. All right, let's do another example. We'll go down here to the bottom of the page. And first, let's do the dimensions to make sure this is possible. And I find that it's helpful if you know what size your answer is. So, first of all, 2 rows and 3 columns. So we've got 2 by 3. Here we've got 3 rows and 2 columns. So 3 by 2. We have the middle ones are the same. And our answer is going to be a 2 by 2. So I'm making a little bit bigger bracket this time. So first of all, this is going to give me, a 2 by 2 has 4 calculations in it because it's got 4 numbers. So first of all, I'm taking this row times this column. So I've got 3 times negative 1 plus 1 times 2 plus 0 times 5. And that's negative 3 plus 2, and I think this gives me negative 1. And if I do any of this mental math wrong, stop me, because this is probably the biggest risk to doing this wrong. That goes here. All right? What goes here is this row times this column. So negative 1 times negative 1 plus 4 times 2 plus 2 times 5. This is 1 plus 8 gives me 9 plus 10 gives me 19. Fair enough? And let's put that here. All right, the term that goes here is this top row times this second column. So I've got 3 times 0 plus 1 times 3 plus 0 times 0. And that's just going to give me a 3. So right here we've got a 3. And the last calculation is this second row times the second column. So I've got negative 1 times 0, 4 times 3, plus 2 times 0, and that's going to give me 12. And there, that's matrix multiplication. All right, let's go ahead and turn the page. What we're going to talk about on this particular page is an identity matrix. So, an n by n matrix, all that means is that they have the same number of rows and columns. So 2 by 2 or 3 by 3 or 4 by 4. An n by n matrix whose main diagonal from upper left to lower right, that's here and here, has all elements of 1, while all other elements are 0. It's called an identity matrix and is denoted with a capital I, n by n. Remember how when we had a 0 matrix, we just could put a 0 and then the dimensions? With an identity matrix, you don't have to write the entire thing out. You can denote it with an I with the dimensions. All right? So this is what an identity matrix is. Let's go ahead. We've got another example here of actually doing some matrix multiplication. And the first one we have is A times B. So let's go ahead and we'll do A times B. And I can see below here we're going to do B times A. So we're going to see what happens when we do that. All right, so first of all, A is a 2 by 2 matrix. B is a 2 by 2 matrix. So the two middle dimensions are the same, and so we can do matrix multiplication. Our ending matrix is a 2 by 2. So here's what I'm going to do. I'm going to start a 2 by 2 matrix. All right, so let's go ahead and we will multiply these two matrices. So first of all, I've got this first row times this first column. So I've got 0 times 2 plus 3 times 1, and that equals 3. So right here we're going to put a 3. All right, let's do this second row times the first column. That will go right here below the 3. So I've got 1 times 2 plus negative 1 times 1. So this gives me 2 plus negative 1, which is just a 1. So we're going to put that in. Now, when we go over to do this particular member, this is the top row by the second column. So I've got 0 times 0 plus 3 times 4. And that's going to give me 12. So that goes here. And lastly, the second row times the second column. So I have 1 times 0 plus negative 1 times 4. And that's going to give me negative 4. So there's my answer. Now, because these are both 2 by 2 matrices, it's possible to multiply them in the reverse order. So I'm going to do B times A. And to be honest with you, I find it very, like, it's confusing to do B times A, looking at them as A and B next to each other. So what I like to do is actually rewrite them. And it just helps avoid the confusion of what goes where. And this is going to give me another 2 by 2 matrix. All right, so here's what we're going to do. The first row times the first column. So I've got 2 times 0 plus 0 times 1. That's going to give me a 0. To get this term, I'm going to do the second row times the first column. So 1 times 0 plus 4 times 1, that gives me 4. All right, to do my second column, on top row, second column. So I've got 2 times 3 plus 0 times negative 1 gives me 6. So that term is 6. And now I've got the bottom row times the second column. So I've got 1 times 3 plus 4 times negative 1. And this gives me 3 plus negative 4, which gives me a negative 1. Now, the purpose of doing this is so that you can see, if you look, when we did A times B, this is the matrix we got as an answer. When you do B times A, you get a different matrix. It's completely different. So the order that you do them in matters. So when you're multiplying matrices, you always want to make sure you're multiplying them in the order that you're supposed to be multiplying them in, so that you can make sure that you're getting the right answer.